In this video, we will see about LDR interfacing with ESP32. Expansion of LDR is a light-dependent resistor. So this device will change their resistance based on the light intensity. If the light intensity is high, that result in more change in resistance. So that will result in there is no flow of current. So the LED which is connected to this ESP32 will be in off condition. If the same LDR is facing with low light intensity, that will result in high flow of current. So the LED is on condition. The same the application for this experiment will be street light. So light depending resistor has been automatic street light controller. So the same application just like a solar street lights also. So here the major component requirements for this experiment is ESP32 development board, breadboard, and LED and LDR light dependent resistor. It is a sensor and required number of resistors for the LED to make on and off conditions, jumper wires as required, PC with Arduino IDE software installed. And along with this Arduino IDE, ESP32 board also has to be installed properly through tools, board and board manager. And coming to the block diagram, here we can see ESP32 is connected with the power supply and LDR sensor input device, and LED is the output device. So this is the virtual image you can see here. This is a way connectivity. And before proceeding to the program, there is another device that is to be seen how the looking of LDR will be. Let us see. Here you can see in this image, LDR has been displayed with the 4-pin device. So in the market, we have a 3-pin device and 4-pin device also. So in this visualization and even the experiment we are doing with the 4-pin. So it has a pin of A0, D0 and ground and VCC. For this experiment, we have been using A0, ground and VCC. So let us proceed with the program understanding with the same device. So here you can see the procedure and followed by the program. So initially we are going to initialize the declaration variable with for the LDR value is a variable initializing with the 0. Then define declaration of another variable is a sensor with the pin number with the 34 and LED is whenever the LDR is detected with high intensity, LED should be off condition, and low intensity and LED should be on condition, that is to be observed. For that you required an LED that is to be connected to the pin number 25. So void setup declaration is been initialized with the program. Here you can see the serial dot begin. So where the once the LDR is reading the light intensity, it is to be observed by the user through the serial monitor. Serial monitor is available in the Arduino IDE itself. So in order to see the LDR intensity values that is been observed through serial monitor, for that you need to start with the serial dot begin line, and 9600 is the baud rate, communication baud rate. So where the data has been transmitted through the to the serial monitor, and one output is LED actuator, and one input sensor is a device, that is a LDR is being declared with the sensor name. Then coming to the execution of the loop, LDR value is being read with the keyword user defined keyword. Sorry, it is a predefined keyword analog read. So LDR is a sensor. So it is been reading the data from external sources. I mean external environment. Analog, it is an analog device. So it is being device the word called analog read. So variable name sensor. Once it is been readed, it is to be displayed in the serial monitor with the word called serial.print. So the quotation inside the word, the same will be displayed in the serial monitor as LDR output value. In the respective value of LDR val, that is a value readed by analog read sensor, will be printed just beside this quoted word. And then if the LDR value is greater than 1500, then it seems that intensity is low. Then you need to print it is a low intensity. Then if it is intensity is low, then you require a light. So that light will be glown through LED. Else case, if the intensity is high, then no need of light. So then you need to make LED to be off condition. So this process will be continued for every 1 second. The LDR is been reading. This process is the program. Let us see the demonstration for this experiment. Now open the Arduino IDE and type the program. So as shown in the manual, this type same the program, and you can use any pin. So sensor has been connected with the 34th pin, that is LDR, and LED actuator is connected to 25th pin. Serial dot begin has to be initialized with the 9600 baud rate. If it is a Wi-Fi or any other connectivity need to be established, then baud rate will be changed accordingly. To see the data read by the sensor in serial monitor, then you need to enter the number called 9600, that is called baud rate. And let us see so in order to, upload the code, you need to do that. Just go to tools, then select board, ESP32, and then select over module. Then once again, go to tools, port, and I have connected my ESP32 to the COM13, that is communication port 13. Select that one. Once it is done, then first do the compilation. Let us see that any errors is been observed or not. So now it shows that done compiling, there are no errors. Let us dump the code. So before sharing the code to the controller, you need to select the board and as well port. Once it is selected properly, the code will be uploaded. So then click the upload button and let us see once again compiling is taking place. So when compared to Arduino UNO ESP32, a bit time it takes for the uploading. So see now the code is writing onto the ESP32. So once it is being shows that hash of data verified, it seems that it is done uploading the code. Let us see the output. Here you can see that ground in expansion board of ESP32. So ground and VCC will be there. So both are look onto the same side. So one line will be ground, and above just beside to the ground you have a VCC. So both grounds, that is LDR ground and even LED ground, both to be connected to the common ground. On the right side, you have a VCC, which is been represented with the 5 volts. This yellow colored is been representing that LDR is been connected to the 5 volts device. And another side, LED is also is to be connected to the respective pin as mentioned. Now here we can see that this is the LDR. This is LDR. So LDR at the top, this part is the LDR, and it is a 4-pin device. 3 pins are being connected to the ESP32. The leftmost pin is the A0, and rightmost pin we have 2 pins, that is a VCC and ground will be there, that is been connected to the ESP32. And here those pins are, if it is properly connected with the help of a resistor and LED, then we can see that on and off condition. This is the LDR, changing resistance with respect to light intensity. So with here we can see that light intensity is very low. That is why LED is on stage. Let us have that if there is a flashlight or high intensity is been incident, by default LED is been off condition. If intensity is high, it is off. Intensity is low, light is on. So this action will continuously. Reading of LDR will take place for every second. Thank you.